All right, so chapter 9. So, by the way, for the ones that weren't here last week, make sure you bring your textbooks as we are back to using our textbook for this topic or this chapter. Yeah, I know last topic, I gave you guys the questions in your notes, but this time, straight textbook. Yeah, so bring it to class, please, moving forward. Okay, so in year 11, like I mentioned, data is one of those things that is a mandatory topic that you have to do if you do general maths, okay? And the reason being is because when you work with data outside of school, okay, it's one of those things that you actually will find useful. You might not think right now, because data's like, oh, isn't that for like analysts and people who like, work with numbers? Actually, no, it's not, okay? Everybody at some point in time is going to use data in some way, shape, or form. Like, for example, I was driving to work this morning, right? And then I was wondering which way I should go to get to work. I have two options. I can either take the main freeway or the back roads. So when I got to the street where it splits into two, I had to look both ways and see how congested the road was on the freeway. Okay, so I looked to the freeway on the left. I'm like, oh, there's a lot of cars. Looks like there's a dead kangaroo in the road. I think I will go to the back way. Now, what kind of data did I use there? What information did I talk about? Literally just that. Well, yeah, okay, let's not even go there yet. What was I talking about? Data, but just the story that I said. Dead kangaroo. What else? Lot of cars, and the main one is which way should I go? This way or that way? Okay, that's one way you can use data. Okay, I know it's silly. Okay, and there's not really any numbers involved there, or you might think there isn't, but it's still data. Okay, when you got to bed last night, okay, some of you, what time did you guys go to bed last night? Give me some times. 9 o'clock. 9:30, 3 in the morning, 1 in the morning. Okay, so when you got to bed at that time, when you're like, oh, how much sleep am I going to get so that I'll be right for tomorrow? Okay, that's data right there. Or even the time itself that I asked you for, that's data. Okay, when I told Jordan to be quiet, okay, why am I telling him to be quiet? Because there's data coming into my head that there's sound coming from there. That's data, okay? Data's everywhere, is what I'm saying. Yeah, you use it all the time. Even though you might not think so, it's very, very relevant. So what we're going to learn about today is basically an introduction to what data is, okay? And in math, generally speaking, we try to simplify it by splitting it into two types. So there's going to be types of statistical data that we're working with. Now, when we're talking about the word statistics, it's just basically information, okay? So types of information, types of data. That's what we're going to look into. And as Elisa mentioned before, the word categorical, okay, that's one type of data, and numerical. So we're going to look into that. So for today, if there's anything that I would like you to learn, is that there's two types of data, okay? And I would like you to be able to distinguish them. Distinguish between those two types of data, categorical and numerical, yeah? Now, when it comes to data types, there's subtypes, so we're going to get into more of that. And then what I would like you guys to be able to ultimately do, so as a higher skill, is be able to identify. So let's say I gave you data, okay? You tell me what type of data it is. Like say, for example, Sophie's, the distance she takes to walk to school. What kind of data is that? Okay, so I would like you to be able to differentiate between that and maybe the breakfast that Tony had this morning. What kind of data is that? Maybe you had nothing. Had an ice sandwich. It was beautiful. Kidding. Do you know what an ice sandwich is? Okay. All right. I'm too old. Anyway, types of data. So there's essentially whenever you're working with data in the real life, what scientists and statisticians like to do is to break it down into two types, okay? Because there's a lot of data, yeah? It's way too much, but you need to be able to sift through it. Because the end goal of having data is you want to be able to make a decision about something or have an idea about it, or maybe like I said, make a decision. So, say for example, you want to buy a house. Okay, what kind of data might you look at if you want to buy a house? If you're like many years down the line, what would you look? Yes, Ecclesia. Price, good. That's the data. You look at what else?
Location.
The location might be important. What else might be important when you're buying a house?
How much money you have.
How much money you got. So with regards to that, how you're going to make money? Your job might be important. That might be a factor. Your family could be a factor. Okay, all of this is data, and the idea behind it is you want to be able to make a decision or make sense of it. Okay, that's the whole point of data. And that's what we'll be able to do, hopefully, at the end of this topic. So let's go back to this. When we're working with data, there's two types. Most people, they like to do surveys. So if you think about a survey, that could be like asking people for their opinion. If someone sends you a Microsoft Forms survey, they might ask you, tell me this, this, this. That's one way of getting data, okay? Generally speaking, with data, they also ask questions. So it could be like Jamie's shoe size. It's a bit weird, but anyway. Or, sorry, it could be the class's shoe size. What is your shoe size? Or it could be, how many siblings do you have in your family? Okay, generally, when it comes to data, there's always a question being asked. Okay, and the idea is you want to generate something meaningful. Okay, so it's all about getting meaning, having meaning in that data. You don't want to just collect data and say, the chair is grey. Why? Like, what's the point of that? Okay, there's got to be meaning to the data, okay? So, these are the two types. Whenever you work with data in Year 11 and Year 12, and obviously Year 10, there's two types that you've got to work with, yeah? These are the two main types. You've got categorical, I can't see that. Yep, categorical or numerical. Okay, those are the two main types. So according to the definitions here, categorical represents a character, a characteristic. One way I would say that is categorical is descriptive. So write that down. It's describing something. For example, you might look at me and describe me as, Mr. Torio is, what's my nationality? Yes, I'm a jalapeno, a Filipino. Okay, I'm Filipino, that's descriptive. So that in itself, there's no numbers involved. It's literally just a title. I am a Filipino. I might go to, I don't know, Nelson. Junior, what nationality are you? Samoan. Okay, so that's descriptive. Okay, that's descriptive data. It has meaning to it. It tells me that Junior is from Samoa or his parents are from Samoa. Another type could be, or another descriptive data would be, Kiara's hair is blonde. That's descriptive, yeah? Okay, so categorical data describes something. It's not necessarily a number. It's just describing a character, or it could be describing a feature about something. It could even be like, I like green cars. That's descriptive. It's data, but it's descriptive. Now, when it comes to categorical data, there's two subtypes. So this is something that you need to know. There's two types of categorical. You either have nominal or you have ordinal. Okay, those are your two subtypes. So you need to be able to tell me if something is categorical, is it ordinal or is it nominal? Now, with nominal data, there is no order, okay? All it's saying is, for example, like what I mentioned, I'm Filipino, Kiara has blonde hair, Junior is Samoan, okay? Jamie is a girl. Actually, nowadays, can't assume that, can we? But, okay, it's just describing something. There's no order. You're just telling me what is what is the quality of something, okay? It's not so much trying to put numbers on anything. You're just telling me what that is. However, with ordinal, you can put it in an order. Now, this is where it gets a little bit tricky, yeah? It depends. So when you start moving to ordinal, this is when you might ask, what is your preference? Okay, or what's the most popular type of thing? For example, or another one could be low, medium, high. What is the most frequently bought shirt size among female, for example? Okay, with ordinal data, just think of it as order. Okay, so it could be low, medium, high, big, medium, small, kind of same thing. It could be maybe likely to not likely. You know those scales where they've got like, in your opinion, what would you most likely come back to this place? Yes or no? Okay, that's ordinal. Another confusing one is think about this. Your address. Okay, when you go down a road in a street, what do the numbers go up and down by? It can go up by twos, or it can go up by odd numbers. Yeah. Even though those are numbers, they're actually describing something. It's your location. So it's not necessarily a number, it's just describing your position. What about a race? First, second, third, fourth. Is there value in the number? Not really, but it's more so a descriptor of what you came. You either came first, second, third, or fourth. Okay, so that's what ordinal is. Okay, so for categorical data, you've got two types, nominal and ordinal. We're going to look at let's look at some examples for now. So here's some examples of categorical data. That's nominal. So nominal, remember, we can flip through it if you want. We'll go back to this though, yeah? We're going to go back to this shortly. But let's look at this. So examples of categorical data, that's nominal. So the list of cars you might see in CS. So you're not actually, there's no order. Okay, you're just listing the cars that you've seen go through CS. Okay, or maybe a list of football team names. There's no order, you're just telling me what team names are there. Postcode of each suburb. Okay, what's a suburb for Caroline Springs? 3023, yeah? Where I'm from in Rockbank, 3335. Now, the number itself doesn't have a value, like it's not mean, median, mode, it's not measuring anything. It's just telling you where you are, okay? So that's nominal. Now, ordinal, a list of car colors on Caroline Springs, arranged by popularity. So now you might start thinking, oh yeah, what's the most popular car color that I've seen? Okay, that's ordinal, because you might say, oh, I saw 1 white, 2 black, 3 yellow. Okay, there's order, lowest to highest. Ranking of football teams. So maybe, for example, you might want to rank the best team to the worst team, or maybe the team that has the most wins to the least wins. Okay, you're going to rank them. Okay, ranking of the most popular appliance brand. So again, it's when it comes to ordinal, you're just telling me like there's order to it, lowest to highest type of thing, and organizing the postcodes in order. Okay, so again, numbers like postcodes, the place you came into a race, maybe the order of the rooms in the school. What rooms are these? This is like from, I think, room RC1 to RC7. Okay, these portables here. Is there value in those numbers themselves? No. Okay, it's just telling you the location of where the room is, but there's order to it. Okay, let's go back. Actually, can anyone give me an example of a categorical data? Maybe in this classroom. Anyone think? It's an example of categorical data here. Yes, Jamie. List of people's names. Great. Awesome. So that would be categorical nominal, because you just tell me their names. Now, tell me this though. List of people's names in alphabetical order. What would that be? Good. It's categorical, but then there's order to it. Okay, let's go to the next one. Thank you, Jamie. Great examples. Numerical. Okay, now you're working with data that has some sort of meaning with the numbers. Okay, some sort of meaning with your numbers. So, generally speaking, when I talk about numerical, it's numbers that it represents, like, say, for example, your age. Okay, most of you are like, what, 15, 16-year-olds? Okay, that's numerical data, because it's telling me how old you are, how many years you've been alive for. Another example could be, let's see, I think Claudette has the longest hair here. So her hair length, okay, is numerical, and that there's meaning in that number. It's telling me how long her hair is. Okay, so think of numerical as it's numbers. Okay, so it's numbers with meaning. And when I say meaning, it's like you can calculate mean, median, and mode. Okay, these words are going to be important. We'll look into them a little bit more down the line with this lesson. But for now, it's numbers where you can calculate your mean, your medians, and your modes. Okay? Say, for example, with your postcode, can I calculate mean, median, mode with your postcode, like 3032, 3055? Not really, okay? It's just describing something. But with numerical data, it's different. Okay, the numbers actually have a value to them. Now, like categorical, in numerical, you've got two subtypes again. You've got discrete or continuous. These are a little bit more easy to understand. Discrete is you literally counting something. So I might count maybe the number of steps I took to school today. That's discrete because I'm counting. Or I might count, another example I'll use is the number of family members in this class. So how many you have in your own class, your own family. Or maybe I might count how many chicken wings I ate at KFC. Torio can eat like a lot, as you can see. Okay, that's counting, that's discrete. Okay, continuous is when you're measuring something. Okay, so when you measure something, like Claudette's hair, that's continuous because I'm measuring it. Maybe time as well is something that you measure. Okay, so when it comes to continuous, you're not counting something, you're measuring either how long something is, the weight of something, or the length of something. Okay, and there's also a range with it, but we won't go too deep into it. So discrete, think of it as counting. Continuous, you're measuring. Okay, let's look at some examples here. Discrete data could be, this is a bit outdated. Does anyone text these days, or do you guys use like Snapchat and Messenger? And text? Yeah, do you know back in my day, so old, we used to have a limit on how many text messages you can send. No cap, yeah, no cap, legit, it was pretty bad. Maximum you could send was probably like 40 text messages in like per month, because that's what your plan was limited to. Okay, which was whack. You guys don't have it, but we had limits, man. Like for example, the amount of internet you could have. I remember back then I used to have maximum on my internet 300 megabytes.
Oh.
Now I don't know how much if you guys know how much that is. It's not a lot. It's literally like one movie or even half a movie, and that's all you can download. And then after that, they'll like slow down how fast you can download something. Okay, so discrete is you literally counting how much of something is. Number of students in a school. So I might even say number of students in this class. Okay, that's discrete. Or discrete data, number of students in each math class. Okay, that might tell me something. Continuous data for numerical, the time taken to type a text message. So Mr. Torio is old sometimes. Actually, I don't need glasses yet, but it might take me like 1 minute to type a text message, whereas for the Handy, it might take like 2 seconds. And I'm literally just saying hello because my fingers are too fat. Average number of students, okay? So when you're talking about average number, you might be talking about the mean, the median. And like I said with Claudette, said the length of something, according to this length and width of a bread loaf. Okay. Can anyone give me one example of numerical data, whether it's discrete or continuous? Not what I've said so far. Any examples? Discrete, numerical data. Anyone want to give me an example? I want to ask Jacob, can you give me an example of numerical data? In this classroom. How about in this classroom? Numerical data. Number of paper. Okay, is that numerical? Is that discrete or is it continuous? Good, because you've got to probably count it individually. Okay. What about who haven't I asked here? You know what? Elisa, okay, you're talking. Give me an example of numerical data that's continuous in this classroom. Remember, it's numbers, but you're measuring. Numerical data in this classroom. In this classroom. Give me something, anything. Okay, what about the length of my HDMI cord? I have to measure that, don't I? So that's numerical continuous. All right, let's just move on to this activity, see if you guys can get it. Now, I want you to write here in this practice sheet. Firstly, on that first column, tell me if it's categorical or numerical. And then, based on that categorical numerical, tell me the subtype. Is it either categorical ordinal or a categorical nominal? Or if it's numerical, is it categorical discrete? Oh, sorry, numerical discrete or numerical continuous? Okay, I want you to do that here. So tell me the type over here, and then tell me its subtype. Okay, so remember with categorical, that applies to this data here. And if it's numerical, that would apply to, the subtypes would be this. Okay, so keep in mind of the subtypes when you do these questions. Okay, I'll give you a few minutes to do it.